All right, expressing open sentences. The meaning and the associated words. Think of this as meaning as what do you think when you see a symbol? And think of this column as your verbal expressions. Your verbal expressions. So when we look at this, we're looking at, I'm going to pause for a moment. I'll be right back. Well, it doesn't appear that I'm going to be able to make this right faster, so we'll just have to be patient. And we were just talking moments ago for you that this equal sign, A equal to B, when we look at that, we should be seeing that and thinking that A is the same or equal to, same as, or equal to. And somehow these guys got switched around in my note packet. Those should be going the other way around. So, meaning that in this box, I hope you wrote that A is equal to B. And then over here in this box, you wrote A is the same as B. I really think that most likely when you read this, these two pieces are a little bit flipped, but they could go both ways. When we look at the symbol, A is less than B, we're going to think, our thinking is that A is smaller than B. Right? No equal to, so just smaller. That's all we know about this relationship is that A is smaller. We don't know how much smaller. When we read it in a math problem, most likely, what you're going to see is A is less than B. So just be careful with that one. Similarly, when we go to that next row, A is less than or equal to or smaller than or equal to. I'm going to fill in that verbal model here. Less than or equal to, because that's what we would say when we read it. Whoa, that got a little off. But these are the two phrases that are probably the most important and the ones that cause students the most difficulty. So what I'm going to do is actually use my little special pen here, my creative pen, and I'm going to put stars next to these because they are that important. These are the ones where people make common mistakes. And while I got my stars out, we're going to see the same thing down here when we get to that greater than situation. So let's talk about that. A is at most B. At most. This is a difficult one, and when I get stumped, I tend to pull out the idea of thinking about money. A is at most B. So I have, at most, $5. Stop and think about that. If I have at most $5, I could have $5, but most likely I have less because I'm pretty broke. Same thing applies here with the phrase no more than. When I look at that, no more than, I have no more than $5. Could have $5, but that's the limit. Most likely I have less. So no more than. They get stars. They get a little bit tricky. You're going to want to practice with those and pay attention when those come up to make sure you're not getting you're not getting tricked. This second to last one, A is greater than B. So when we see that, we're going to think that A is bigger than B. A is greater is most likely what we're going to see. It's what we're going to see when we're given a verbal model. A is greater than B. So we finish this one up, right? A is greater than or equal to B. We'll fill it in here. Greater than or equal to B. So if we use this idea of the star ones over here, what could we probably see? What would we expect in a verbal model? We would expect A is at least B, or A is no less than B. A is no less than. No less than B. At least. I have at least $5. Got $5, but most likely I have more. A is no less than B. I have no less than $5. That one's pretty obvious. That one doesn't stump us too much. I have this little note here underneath, and I want to make sure that you get it filled in because it's really an important part to where we're headed next. Remember that the key word for using an inequality is, in fact, the word is. Talking about when we're going from a verbal model to an algebraic model. When we see that word is followed by one of these phrases in the associated words column, that's how we're going to know we need to use an inequality as opposed to using subtraction or addition. So when we think about a problem, well, let's do some practice here. Given a verbal sentence, write the algebraic equation or inequality. When I start these problems, I always start by looking for that word is, because that tells me where the open sentence is balanced. Is, in this case, is 25. So actually the right side of this problem balances out pretty quickly. Equals 25. Well, what equals 25? That's at the beginning of the sentence. The sum, well, we know that sum tells me I might need parentheses, not always, but I might need to use them. 3 times a number, 3 times, let's use that little multiplication sign, and a number A. Well, we're just going to replace all of that with the letter A. So 3 times A and 4. Well, what's happening between 3 times A and 4? A sum, an addition. So this addition problem is 25. So all we have to do is clean it up. We would never leave that dot for multiplication in algebra because we know that we smush them together. 3 times A plus 4. Let's work through a quotient problem. The quotient, that's division. And since we're now in algebra, we're not going to use that old-fashioned division sign. It's not so friendly. It confuses people, and I like fractions, and I'm gonna make you love fractions this year. So when we look at that, we're gonna go ahead and we're gonna read that word quotient, and we're gonna think fraction, fraction, fraction. So a fraction, the first thing that you see, so in this case, a number x is gonna go in the numerator. The second piece is going to be 4. That goes in the denominator. So the first part of the quotient goes up top. The second part of the quotient goes down below. Is, and this is followed by an inequality statement, is fewer than. So this fraction is smaller than 10. The quotient of a number and 4 is fewer than 10. And I don't know if you've ever been stumped by which inequality to use when, but when you look at this, I always think that the smaller piece, the smaller part of the inequality, should always go to the smaller part of the symbol, so that the fraction is at the little end and the 10 is at the big end of that inequality. Let's keep working through these together, because I know sometimes you struggle. If you think you have it and you want to practice with some explanation, then I would pause it here, practice these two problems, and then come back and listen and see how you did. If you're really troubled and you're having some trouble, I'm going to work all the way through them now. The product of 6 and a number D is at most 49. Product, that's multiplication. Oh wait, there's my is, so I don't get lost in the problem. Is at most. So that's definitely an inequality statement, right? The box is a big one, as opposed to just an is. Is at most 49. So we know we end with a 49. I have at most $49. So whatever it is that I have, once I translate that sentence, has to be smaller or equal to 49. Let's write down an expression for what I have. Let's finish this inequality. The product of 6 and a number D. 6 times D. A number n is greater than 6 and less than 12. A number n is greater than 6 and less than 12. A number n is greater than 6. Well, we would want to make sure that we stuck, so when we read this, it would be smallest to greatest. So small number is 6. So how does my inequality symbol need to go in so that n, this number, is greater? N is bigger than 6. And that same n is also less than 12. Notice the box here. Sometimes two inequalities are combined. For example, the inequalities A is less than B and B is less than C can be combined to form the inequality A is smaller than B while B is smaller than C. So it says both of those pieces. The fact that B is bigger than A and B is smaller than C. This one right here, this letter D, it takes some practice. I would anticipate seeing quite a few of these as we go through and we start practicing more.